Hi class. Today we're still going to be in chapter 1, but we're actually going to finish it today. So we're going to go into section 1.8. This is about constructions. And this is base geometry constructions. We have one objective in this class, in this lecture. And what it is we want to make basic construction using a straight edge and a compass. Unfortunately, it's going to be hard to see some of this um, just through video, but I'll do my best to explain it, and then you'll actually get a chance to do some of your own constructions in your journal assignments. All right, let's start with some basic definitions. So a straight edge is a ruler without markings on it. What we want to use a straight edge for here is not to measure distances at all in this class. It's just going to be something that has a straight edge to it. That's all. All right, a ruler will work, but try do these things or try them on your own to use it without a ruler, with just a general straight edge. So a compass is a geometric tool used to draw circles and parts of circles called arcs. Right. So you probably have used a compass a long time ago in, gosh, maybe even middle school. Right. So a construction is a geometric figure drawn using just a straight edge, not a ruler, a straight edge, and a compass. All right, so I want to do just a bunch of examples today about making these constructions. All right, so I want to construct, or here's an example about constructing congruent segments. So construct a segment congruent to this given segment, AB. Now remember what a congruent segment is, it just has the same length. So now here's the thing, what we don't want to do. We don't want to use a ruler. Like you could just really easily just measure that distance here, but we don't want to use a ruler to do this. All right, so we're given this segment AB, and we want to construct, that's what we're talking about with constructions, segment CD. That segment CD is congruent, same length to AB. All right, here's how you do that. First thing you're going to do is you're going to draw a ray with endpoint C. All right, so here's C, like remember we're looking for a segment CD, and it's a ray. So remember a ray goes on forever, right? This is a segment that stops, so we're going to draw a ray that goes on forever. The second thing we're going to do is we're going to open the compass, right? And this is what a compass looks like, right? To the length of segment AB. So we're going to go back to AB, and we're going to set our compass one edge here at A, and then the pencil side, right, of the compass to go to B. With the same compass setting, so you're going to set your compass, and you are going to leave it at that length. You're like going to lock it in, right? So with that same compass setting, put the compass point on C and draw an arc that intersects the ray and label the point of intersection D. So here's what you're going to do. You're going to put the metal point on C, and then you're going to draw an arc that intersects that ray. And where it intersects that ray, D, this point CD is now the exact same length as AB. So you have just made a congruent segment. Right? So you would put C and then point D, boom. That from here to here is congruent to that segment AB. All right, this one's a little bit harder. All right, construct an angle congruent to the given angle. All right, so I've got this angle A, right, and that's this distance or that angle right here, right? So we want to construct some angle S, right, so that it's congruent to angle A. Right, how the heck are we going to do that? First thing we're going to do is we're going to draw an endpoint, or excuse me, draw a ray with endpoint S. Right, so just like before, we'll start with a very, very simple ray. The next thing you're going to do is with the compass point on vertex A, so you're going to go back to the original one, draw an arc that intersects the sides of angle A, right? And label the points of intersection BC. Now here's the thing I want to stress. It doesn't matter what length you pick this right now, all right? Try to find something that like maybe goes a little bit more than halfway. All right, we're going to come back and use those, all right? So I've got angle, I've drawn on my original one, original angle A. I've just drawn this arc with my compass that intersects at points C and B. All right. With the same compass setting, put the compass point on point S, so that other ray that you just drew, and drew an arc and label its point of intersection with the ray as R. So Here's your R. This R is going to correspond with this C right here. The next thing you're going to do is open the compass to length BC. So here, you're going to go from here to here and put the compass down and measure that length. Right? Keeping the same compass setting, put the compass point back on R, draw an arc to locate point T. So this compass setting here, all right, this length here, go back, is the same. You went from C to B right here like that. And all you're going to do is draw an arc that intersects that original ray or original arc you drew R. Next thing you're going to do is you're going to draw a ray, ST. So you're going to draw a ray right through that intersecting point there, right? That right there, those angles are congruent now, all right, such that angle S is now congruent to angle A. Just like that. All right, let's start with another definition. This is about perpendicular lines. Perpendicular lines are two lines that intersect to form right angles. Right? So they intersect to form four right angles, as you can see over here. Like my line AB is perpendicular with line CD because where they intersect forms four right angles. The symbol, this, looks like an upside down T, right? This means perpendicular to. So in the diagram, as I said, line AB is perpendicular to line CD, and line CD is perpendicular to line AB. So that's just perpendicular lines. Now, a perpendicular bisector of a segment is a line segment ray or even a plane that is perpendicular to the segment at its midpoint. So say we have this midpoint of the segment GH, this perpendicular line EF here, right, because it goes right through the midpoint and is perpendicular at the midpoint, it's called a perpendicular bisector. All right, let's talk about constructing perpendicular bisector. Right, so construct a perpendicular bisector of the segment AB. So I have this line segment. Right, remember, a perpendicular bisector is a straight line that goes through the midpoint and forms four right angles. All right, so here's what I'm going to do. All right, I want to construct some line XY so that XY is the perpendicular bisegment of this segment AB. Here's what we do. Step one. Put the compass point on point A and draw a long arc as shown. I'll show you in a second. Be sure the opening is greater than 1/2 of AB. So I'm going to put my compass here. All right, you're going to be a little bit of an eyeball, right, but it wouldn't be too much. And just draw this segment so that you're sure it is greater than 1/2. The next thing you're going to do with the same compass setting, so it's the same exact size, put the compass on point B, all right, over here, and draw the same arc, another long arc, right? Label the points where the two intersect at X and Y right there. Next thing you're going to do is you're going to draw a line XY through those 2 points. Label the points of intersection of segments AB and line XY as M right here. That right there is the midpoint of AB. And as a result, that line XY, is the perpendicular bisector. All right? So XY is perpendicular to AB at midpoint M. So the line XY is the perpendicular bisector, of segment AB. All right. Now let's talk about constructing the angle bisector. All right, so construct the bisector of angle A. All right, so I've got this angle A. What I want to do is I want to draw the bisecting ray, right? The bisector of that angle. So it cuts that angle in half. All right, so you're going to start with angle A. All right, you want to construct some ray AD. That's the construct you want to make. That is the bisector of angle A. All right, so the first thing you're going to do, put the compass point on vertex A. Draw an arc that intersects the sides, so both sides of angle A, and label those intersecting points B and C. So what you're going to do, you're going to put your compass here, and you're going to draw an arc that intersects both sides of that angle, like that. This will be B, this will be C. The next thing you're going to do, you're going to put the compass point on point C. So you're going to take your compass and put it right here and draw an arc, right? And this is with the same compass setting, draw an arc using point B, right? Be sure the arcs intersect and label the point where they intersect as D. So you're going to start here. You're going to draw an arc out here. You're going to put your compass here. You're going to draw an arc out here, just like that. So C, the arc look like this. B, the arc look like this, right? Where they intersect is that D. Next thing you're going to do is you're going to draw ray AD. And it turns out that that ray that you draw AD is the angle bisector of angle CAB, which is the same thing as the bisector